Alright, so Unit 6, Day 7. We're looking at radicals, but specifically cube root equations. Okay? So before, in this unit, we know that the parent function f of x is equal to the square root of x looks like that. Okay? What we're adding to this for today is our new parent function that the cubed root of x is going to look a certain way as well. And that one is this right here. Okay? 0, 0 is where this one has a center at 0, 0, and 0, 0 here is when the square root function begins, you could say. Alright? So the two questions we're looking at is it more efficient to solve an equation with rational exponents or in radical form? That means if I have like x to the 1/2 is equal to, let's say, 10, is it more efficient than if you saw it this way? Go with me? And then our second question is there a way to tell how many solutions we will get to a radical equation? Okay, that's what we're going to look at today. So first of all, which one, option 1 or option 2, do you feel is easier to know? What do I do to solve this? 2. A lot of people like 2 because that's the notation they're used to. Okay, what would you do to solve 2? You square both sides. Here we go. When you square both sides, the left side becomes x and the right side becomes 100. No plus and minus because you're squaring. Okay? So this is the answer to what you originally had there in option 2. Now, if these two are equivalent, that means I could do the same. I could raise this to the power of 2. I could raise this to the power of 2. And this is something new that you have to learn today to understand how do I get rid of fractional exponents that appear to look like they're difficult to work out. Okay? Well, if it's 1 over 2, we're going to raise it to the power of the reciprocal, which is 2 over 1. Go with me? I'll say that again. If it was 2/3, you would raise it to what? 3/2. If it was negative 1/2, you would raise it to what? Negative 2 over 1. Because your goal is a power raised to a power, you multiply. And what number will that multiply to become? 1. Because then it's not there anymore. So x to the power of 1/2 raised to the power of 2 will become x to the 1. And since you squared the left side, you'll square the right. You again get x is equal to 100. Questions? Pretty basic, right? You're just trying to get that power to a positive 1. Or you raise it to the power of the reciprocal. This is big with what was just said. Because if I have 1/2 and I told you to raise it to the power of the reciprocal, some people say I'm going to multiply by 2 over 1. That's not true, because if you multiply by 2 over 1, you get this. So I want to make sure that you understand. I know you knew what you meant, but you're not multiplying by 2 over 1. You're raising the left side to the power of 2 over 1. You're raising the right side to the power, of 2 over 1. Okay? So these are easy, guys, when this is 1. They're easier. Okay, let me show you an example of what I'm talking about. Let's say that we had x to the power of, let's say, 2/3. Okay? And I had it equal to, let's say, 16. Help me solve for x. What would I do? I'd raise it to the power of 3/2. What number did this left side become? 1. So you don't need it. It's just saying x. And now we have to decide what do we do on the right side without a calculator. Okay? On the right side, it looks like this, which is the same as that. Now you tell me, do you know 16 cubed off the top of your head like that? You don't. because of multiplication being commutative, where order doesn't matter, instead of doing that 3 first to 16, I can actually do the root first. So I could take the square root of 16 and then raise that to the power of 3. You see what I'm saying? It's so much easier that way because you're going to work with small numbers. Go with me? So what's the square root of 16? 4. 4 cubed? 64. So 64 would be the answer for x here. The other way around is a little bit of a nightmare. 16 cubed, a lot of people don't have that memorized. You know what I mean? And then to square root it afterwards, you don't have that memorized. Break it down to its fundamental roots, its lowest roots. Alright, so let's keep going. Any questions before we start jumping into today's lesson? From what we've done so far. Okay, so let's look at comparing these two. Okay, we have f of x, again, is equal to the square root of x. We know what that looks like. We now have this new parent function, which is the cube root of x. And transformations wise, everything is pretty much the same. Can you tell me what the domain of cube root is just first? All real numbers. What is the range? All real numbers. How about over here? What's the domain? 0 to infinity. Some people said x is greater than or equal to 0. And then what's the range? 0 to infinity, or y is greater than or equal to 0. Okay, just a little review, making sure we're good to go. Now, let's say that I looked at this function and I created a transformation that looks something like that. Okay. The way we transform this with B, C, A, D order, we will also do the same over here. Same thing. Only its parent looks a little bit different. So what's inside with x, is going to be horizontal movement or horizontal change, and everything on the outside is going to be vertical change, up and down. Looking at my example over here, can someone tell me in BCAD order what happens first over there? Horizontal compression by what? By 1/2. Yeah. Second, what transformation do y'all see happening over there? Shift to the right 3. Nice. Because remember on the rules of transformation, I said the most important thing that you need to do before you start interpreting this BCAD order is that you have to GCF that coefficient of x to become what number? 1. And you hear me say this a lot in math. There's so many cancellations of 1, so many things. Whenever it's 1, it's easier to work with.
So you just took out the 2 and made the 6.
So I'm going to take out the 2, like GCF, and everything else is still going to remain the same. Because now I can interpret, it's not a 6 horizontal shift 6 to the right. It's actually a horizontal shift how many to the right? Just 3. So horizontal shift 3 to the right. Yes? If there wasn't a negative 2? Yeah. It's a horizontal compression. Yes, it would still be that one that we mentioned right here, number 1. So the horizontal compression, let me kind of do this color-wise. This right here is the horizontal compression by 1/2.
But then you would still do the...
Oh, okay, so that's what you're asking. The second thing that you're going to be looking at is C. Okay? BCAD. C is over here, not here. So the change that is happening is that shift 3 units to the right. Then the following one is going to be A, which is what's happening right here. You see what I'm saying? And there's 2 of them actually happening right there. And then the last one will be D. Again, color coordinating this. Hopefully it helps by doing it like that for you. All right, so you tell me, what's the third change that you see? Yes, vertical reflection across what? X-axis. Vertical reflects, or you could put reflection across X-axis. Okay, and then vertical stretch by a factor of 2. I'll just put by 2. And then what's the last one? Vertical shift 4 units up. Or translation 4 units up. Questions? Pretty good, right? All I have to remember to do is I have to GCF the coefficient of X to V1 and then read BCAD order, and you should be good. Thank you for asking that, Nishi, because I think that did help a lot when some people didn't realize the order. Yeah?
I said that's all you have to do.
That's it for transformations. Because this graph that we just created, well, here's the thing. If you don't have a calculator, you should create pivot points that you don't necessarily have to do 30 different points. But 3 points is a good rule of thumb, okay? We all see that 0, 0 is probably going to be one of them. What are other points that you could use based off of this equation right here? 1 and 1, which is right here. And what other one? Negative 1, negative 1, which is right here. You with me? So here we go. Let's pick 0, 0, and we're going to go through all of these transformations and see what happens to 0, 0. You see what I'm saying? Yeah.
If the vertical stretch and the horizontal compression are the same number, will they cancel out?
Let's come back to that question. That's a good question, but let's come back to that, okay? So 0, 0. If I horizontally compress, that means I'm going to multiply the x value by 1/2. You with me? What does it become? 0, 0. Okay? Okay? So again, I'm going through them step at a time, and the first one that was here was the horizontal compression by 1/2. Okay, now let's do a horizontal shift 3 to the right. What does it become? 3, 0. Then we're going to vertically reflect across the x-axis. That means I'm going to multiply all the y values by what? Negative 1. So what does 0 times negative 1 give me? 0. And then I want to vertically stretch by 2. That means multiply the y value by 2. What will it become? 3, 0. And then last but not least, let's shift this 4 units up to become what? 3, 4. So guys, our transformation, which is right here, will end up graphing 0, 0 will go to 2, 3, 2, 3, 4. It will end up going here. Okay? Let's move 1, 1. Again, each step of the way as we went through these 5 transformations, I'm highlighting, okay, this was x, then it was a vertical reflection, then it was a vertical stretch, and then it was a vertical shift. Let's change 1, 1. 1, 1's first change will become what?
2, 1.
Not 2, 1. 1/2, 1. Because you're multiplying by the compression of 1/2. Okay, so 1/2, 1. Then now shift 3 to the right. So it's going to add 3 to this ugly fraction, right? So if I add 3 with a denominator 2, it's like adding 6 halves, which would be 7 halves 1. Okay? All we did is add 3, otherwise 6 over 2. Common denominator gets 7 over 2. Now let's vertically reflect. 7 halves, negative 1. Now let's vertically stretch by 2. 7 halves, negative 2. And vertically shift 4 up. 7 halves 2. So this 1, 1, okay? Okay, so remember the first one that we were working with was 0, 0, and that moved here. This second one that we're working with is 1, 1, and this moved at 3.5, 2. So 3.5 is about here, 2 is about here. That's where that point moved to. Okay, and now let's finish it off with this negative 1, 1. Oh yeah, negative 1, negative 1. Thank you. So compression, it would be a negative 1 half, negative 1. The shift 3 to the right, it's going to be 2 and a half, right? So 2 and a half is what? 5 halves, negative 1. Then reflection across the x-axis. So you're going to multiply the y value by negative 1. Makes it positive. You're going to vertically stretch it by 2. And then you're going to shift it 4 up. So 5 halves is about 2.5, right? All the way up to 6. So 2.5 all the way up to 6. I know I'm kind of, but it's going to be coming up here. So my transformation, all that good stuff, let me kind of make it predominant to stand out, will look something like that per se, with all the transformations that occurred. Any questions? Now you know how to do it like a point. You know how to interpret it by GCFing out the denominator or the coefficient of x. It's pretty basic. It's kind of like still the same transformation knowledge you're already good at.
So we do that just to get the endpoints?
Yeah, the way I showed you with the points is if you don't have a calculator,
That's how you plot it.
that's how you do it. You're still going to look at your list over here and say, all right, from horizontal, horizontal, and so on and so forth, the vertical changes. Am I adding, multiplying, whatever I'm doing as I go through.
So if we did all that, we would just plot or like make the new line?
Yep, just like I did.
3 points?
Yep, those 3 points. And 3 points is good enough. They're pivot points. And then you could, because with only 2, it's not good enough for you to see what the graph is going to accurately sketch out to be. Alright? Any questions? Alright, so we're going to move on to our next part of today's stuff.